The aircraft sitting on the Beechcraft stand at the 1983 NBAA convention did not look like an aeroplane. There was no tail. The propellers were mounted backwards. A second wing sat ahead of the cockpit, and the whole airframe was molded out of composite. The announced price was $2.7 million, and they positioned it as the next-generation turboprop that would make the King Air obsolete. But 12 years later, only 11 had been sold to private owners, and in 2003, most of the surviving fleet were flown to a boneyard in Arizona, stripped, sawn apart, and incinerated. So how did the most ambitious turboprop ever built end up destroyed by its own manufacturer? To understand why, you have to start with the aircraft it was meant to replace, the King Air. By 1979, the King Air family had helped Beech capture roughly half of the business turboprop market. And the reason comes down to the fact that the King Air worked. It had been flying for 15 years. It was reliable, proven, and making Beech a lot of money. But Beech knew that kind of dominance does not last forever. Competitors were closing in from below. Cessna had the Conquest, Mitsubishi had the fast compact MU-2, Piper had the Cheyenne, Swearingen had the Merlin, and above all of them, Cessna's Citation family was pulling the richer buyers upward toward jets. Beech was being squeezed from both ends, cheaper, proven turboprops from below, and faster jets from above. Fuel prices had also spiked after the oil crises, so the whole industry was chasing the jet-like speed without jet fuel burn dream. So Beech set out to build its next-generation business aircraft. It had to cruise at 400 miles per hour, seat 10 people, and stay under 12,500 pounds gross weight. For context, the King Air 200, which was Beech's flagship turboprop at the time, cruised at about 330 miles per hour, carried up to 9 passengers plus 2 crew, and had an empty weight of roughly 7,500 pounds. So the target was aggressive: big cabin, more speed, and better economics than a jet. Beech studied everything from normal layouts to properly radical ones, but the answer kept pointing in the same direction. A conventional all-metal airframe was not going to hit those numbers without getting too heavy. That is where composites entered the story. By 1982, Beech had the mission defined. Internally, it was called Preliminary Design 330. But Beech still had a problem. It wanted to build a radical composite aircraft, and it needed someone who understood that world properly. So they brought in Burt Rutan's Scaled Composites. And Scaled was tasked to refine the concept, build an 85% scale proof-of-concept aircraft, and do it fast enough for Beech to decide whether this thing could actually go into production. Scaled delivered. The proof-of-concept aircraft was built in roughly 9 months, flew for the first time on the 29th of August 1983, and logged its first 100 test hours in just 35 days. And one of Scaled's big contributions was the moving canard. The forward wing could sweep automatically as the flaps changed, helping the Starship manage pitch and trim through different phases of flight. So the basic aerodynamic idea worked. But by the time Beech had proof that it worked, the company had already made the decision that would shape the whole program. Because just 6 days after giving Burt Rutan the proof-of-concept contract, Beech started designing tooling for the production Starship. The demonstrator had not flown, it had not produced a single hour of test data, but Beech was already committing to the production aircraft. And that mattered, because if the proof of concept had flown before production tooling began, it could have had a much bigger impact on the final Starship. But it did not, and once Beech locked itself in, the Cascade began. The original target was 12,500 pounds gross weight. And that number mattered because staying under it would have kept the Starship below the FAA type rating threshold. So any qualified multi-engine pilot could have flown it without needing a separate type rating. But the hand-laid composite structure came out heavy. Then the FAA wanted the airframe strengthened further, and once the weight started climbing, everything else had to follow. Empty weight rose by roughly 2,400 pounds above the original plan. Gross weight ballooned to 14,900 pounds, blowing straight through the 12,500 pound target. Now the Starship needed a type rating. Then the engines had to grow. The original 750 shaft horsepower class engines were replaced by 1,200 shaft horsepower Pratt & Whitney Canada PT6A 67As. The propellers grew too, from 94 inches to 105 inches. The cabin lost 2 passenger seats, and the price kept climbing. Beech had announced the aircraft at $2.74 million in 1983. By market entry in 1989, it was $3.9 million. By 1993, the later 2000A variant was around $4.7 million, with some reports putting early 1990s pricing as high as $5.3 million. So by the end, Beech had a turboprop that was heavier than planned, thirstier than planned, more expensive than planned, and now sitting in a price bracket where buyers could just buy a jet. The first full-scale prototype flew on the 15th of February 1986, followed by 2 more test aircraft. But even then, Beech was still chasing the aircraft. Between the Starship's conception and its FAA type certificate on the 14th of June 1988, the chief engineer personally signed 50,000 change orders across more than 2,000 engineering drawings. Major design changes were still being made at the end of May, just weeks before certification. Inside Beech, the leadership was changing too. From 1982 to 1989, the company went through 3 presidents and 4 engineering vice presidents. On a normal aircraft, that would be disruptive. On a radical composite canard pusher with a glass cockpit, it was poison. So by the time the Starship reached service, it was not just overweight and overpriced. It was a complicated new aircraft that had been rushed, reworked, and compromised almost to the finish line. And once the early fleet went to work, that showed up quickly. Starship suffered repeated air conditioning failures, door seal problems, bleed air valve defects, and brake issues. And in business aviation, that kind of thing spreads fast. Flight departments talk, owners talk, pilots talk. Reputation moves through the market long before the sales brochure does. Beech did fix many of those problems. Later aircraft were much better, and some had few, if any, of the same defects. But by then, the damage was done. Buyers admired the Starship. They talked about it, they photographed it, but when it comes to writing the check, they all walked away. In the first 3 years after certification, Beech sold only 11 Starships to private owners. The rest were placed on lease because almost nobody wanted open-ended ownership of such an unproven machine. By 1992, Beech was leasing Starships for $25,000 a month. At one point, the company even offered free maintenance to pull buyers in. But even with that, buyers still shrugged, and the price did not help. Because at $3.9 million in 1989, the Starship sat in the same bracket as the Cessna Citation 5 and the Learjet 31. Both were jets, both were much faster. The Citation 5 was 89 knots quicker in maximum cruise. The Lear 31 was 124 knots quicker. Even the Piper Cheyenne, a turboprop, was faster and cost about $1 million less. Then the timing made it worse. The Starship entered service as the United States economy was sliding into recession. Business aircraft sales were soft, and a federal luxury tax was punishing exactly the kind of high-ticket purchase the Starship needed. Even proven aircraft struggled in that market. The Starship was not proven. But the cruelest problem of all was sitting in Beech's own showroom. The King Air never went away. It stayed in production. It kept selling. And it kept building the one thing the Starship desperately needed: trust. And when buyers compared them side by side, the Starship had a problem. The King Air flew almost as fast. It could carry 2 more passengers. It had a near bulletproof service record. The King Air 200 did not need a type rating, and the support network was already everywhere. So every serious buyer came back to the same question: why take the risk? In late 1994, Raytheon announced that Starship production and marketing would end in 1995. The last airframe rolled off the line that year. The program was openly unprofitable, and one contemporary report described the market's response as overwhelming rejection. But Raytheon still had a bigger problem. It owned most of the fleet, as many as 40 of the 50 production aircraft, and supporting that tiny, complex, orphaned fleet meant carrying specialist parts, many of them unique to the Starship and no longer being made by suppliers. So in 2003, Raytheon decided the cost was no longer worth it. The company flew most of its Starships to the Evergreen Air Center at Pinal Air Park in Arizona. There they were stripped, sawn apart, and incinerated. Today, only 4 Starships remain airworthy worldwide. two are operated out of Addison Airport near Dallas by Aerospace Quality Research and Development. Their survival now depends on a tiny group of owners who refuse to let the type die. And the thing is, the Starship was not a bad aeroplane. Strip away the commercial disaster, and what you find is one of the most technically ambitious business aircraft ever built. See, in a normal aeroplane, the tail usually pushes down to keep the nose in balance. That works. It is stable. But it also means the tail is fighting the wing a little. You're carrying a surface that helps control the aircraft but does not really help lift it. A canard changes that. The front wing is doing useful work. It produces lift instead of just pushing down. And on the Starship, the canard was not there just because it looked futuristic. It had variable sweep and moved automatically as the flaps changed, helping the aircraft manage pitch and trim through different phases of flight. That is why the stall behavior was so clever. The forward wing was designed to stall first. So instead of the main wing quitting and the aircraft snapping into something ugly, the nose dropped, the main wing kept flying, and the aeroplane recovered itself. Which meant the Starship was, by design, extremely difficult to spin. It was also quiet. With the PT-6s sitting behind the cabin instead of beating prop wash beside the passengers, the Starship had a cabin and cockpit that felt nothing like a normal turboprop. Surviving operators have said that above 25,000 feet, the cockpit is so quiet they do not even wear headsets. And this is where the Starship gets frustrating, because the ideas were not wrong. They were early, and the composite structure proved that. The Starship became the first FAA-certificated civilian aircraft with a pressurized carbon fiber fuselage, and years later the material held up better than many people expected. Because in 2017 the FAA tore down the aft wing from a retired Starship after 12 years in service and around 1,800 flight hours and found no significant structural degradation. So the composite worked. The material was not the weak link. The problem was the manufacturing process. Beech was trying to build tomorrow's airframe with 1980s production methods. And the cockpit told the same story. The Starship carried a 14-tube Rockwell Collins Pro Line 4 all-glass cockpit, the first in a certificated general aviation aircraft. Today, glass cockpits are normal. In the mid-1980s, that was wild. But the technology was not mature yet. Those CRT displays were heavy, roughly 460 pounds of screens sitting in the nose, and they threw out so much heat that avionics cooling became operationally critical. The Starship was an unfinished revolution sold to a market that pays for certainty. Beech guessed the future's shape remarkably well. Composites, glass cockpits, efficiency, low noise, but it delivered all of it in one massive leap, instead of in steps the market could trust. And that is the frustrating part. Almost everything the Starship pointed toward later became normal. The 787 flies with composite wings. Glass cockpits are now in everything from Cessna 172s to Gulfstreams. And the Piaggio Avanti proved that a pusher turboprop could sell. So, that's it for today's video. Don't forget to like, subscribe, and ring that notification bell. It goes a long way for us.